This is the lateral arc pressure in active condition. This is the general equation, and this equation is used for cohesive soil where the value of C and value of phi both are there, and for cohesionless soil when the value of C is equal to 0, then we can use this equation. Okay. These up to this we have discussed in the previous class. Now we'll go to the next topic, that is earth pressure in passive condition. Okay, now now I'm showing the equations we have used in the active condition, that is these equation, the relationship between major principal stress and minor principal stress. Major principal stress is sigma 2 and minor principal stress is sigma 1. This is the relationship between major and minor principal stress. And in case of active pressure, lateral pressure in active condition, this sigma 1 is equals to the vertical this sigma 1 is equals to the lateral arc pressure, and sigma 2 is equals to the vertical arc pressure. Vertical arc pressure is nothing but gamma multiplied by h, and sigma 1, which is lateral arc pressure, is represented as PA. Now in case of passive condition, we have to derive equation for PP. Small p in suffix capital P. Okay, this is this. For this PP we have to derive the mathematical equations. Now coming to the figure coming to the figure these portion for this portion we have discussed earlier that for this portion, when the lateral movement of this returning structure or returning wall, this returning wall is moving towards this fill. This is one type of fill. This is not backfill, but this is one type of fill, that is this fill is done for the embedment depth. These types of embedment depth is mandatory for any returning structure which have some backfill soil or backfill material. Now for this, as an example for this wall is moving towards this field. This is the original shape. The straight line, farm line is the original position of the returning wall, and the dashed line, this dashed line is the modified position of the returning wall. And as this wall is moving towards this, by the definition there will be a passive earth pressure, passive lateral earth pressure generated, and these types of passive lateral earth pressure, for these types of passive lateral earth pressure we have to derive mathematical equation. Now we have to use the same equation as we use it for the active earth pressure, and the basic equation we have to use is the relationship between the major principal stress and minor principal stress, where major principal stress is sigma 2 and minor principal stress is sigma 1. But here the difference is that as the movement of this wall is due to the lateral earth pressure, and the movement is increasing. As the movement will increase, the value of passive earth pressure will also increase. In case of active earth pressure, as the movement or the displacement of this wall will increase, the active earth pressure will decrease. In case of active earth pressure will decrease as the movement is increased. But when the movement is increasing, then the passive earth pressure will also increasing. That's why in this case passive earth pressure PP, passive earth pressure will be considered as major principal stress. Passive earth pressure will considered as major principal stress sigma 2. Here in this case, in case of active earth pressure, we have considered the major principal stress as the vertical pressure. Vertical pressure will be considered as major principal stress, but in case of passive earth pressure we have to consider the lateral earth pressure, lateral passive earth pressure as the major principal stress, as because due to these passive earth pressure the value of passive earth pressure will increase as the movement of the wall will increase. That means the movement of the wall is actually due to the vertical pressure, and the reason of the movement is due to the vertical pressure. Now as the vertical pressure increase, active pressure increase and the movement increase, but in a equilibrium condition, when the movement will increase, active earth pressure will decrease, and at some point of movement the active earth pressure will having a constant value. But in case of passive pressure, as the movement is increasing, the passive earth pressure, lateral passive earth pressure will also increasing, and that's why the increasing value of passive earth pressure will be considered as the major principal stress, which is here, which is sigma 2. That means here sigma 2 equals to major principal stress is actually PP, or passive lateral earth pressure, and sigma 1, which is minor principal stress, is actually the vertical pressure, which is gamma h, or maybe you can write down that vertical earth pressure. This is the mathematical difference of active earth pressure and passive earth pressure. Now, now putting these forms, these values of major principal stress and minor principal stress, we may have the modified equation in place of sigma 2. We may write down PP, that is lateral passive earth pressure, and in place of sigma 1 we may write down gamma H, that is vertical earth pressure. This is very much simple, that now we have a equation of PP, mathematical equation of passive lateral earth pressure. We have the equation instantly. That's why we don't have to modify this equation, but we have to just put the value or the equation for n phi. N phi, the equation for n phi is this one. We have derived the equation for n phi by putting the formula of tan a plus b the whole square, but these value we have to put here also. N phi is, please see this one, n phi is 1 plus sin phi divided by 1 minus sin phi, that is here we may 1 plus sin phi divided by 1 minus sin phi plus 2c root over of this one. Okay, this is the final form of equation for PP, that is lateral passive earth pressure. Okay, this is the final form. Now coming to the case as in case of cohesion-less soil or cohesive soil. For cohesion-less soil, for cohesion-less soil, where C is equals to 0, then PP is nothing but or KP. Here this one is Ka, that is coefficient of active earth pressure. Here Kp is nothing but coefficient of passive earth pressure, and Kp multiplied by gamma h, where Kp equals to coefficient of passive earth pressure, which is equals to this one. And now this is clear that for cohesive soil where there is a value of C, you have to use the general equation of passive earth pressure. This is for cohesive soil. Now this one is Kp and this one is root over of Kp, as this one root over of K, this one is Ka, this one is root over of Ka, like that. Here also this one is Kp and this one is root over of Kp. Now I think you can derive the relationship between Ka and Kp, that is Kp is equals to 1 divided by Ka, that is reciprocality is one another, that is Kp is equals to 1 divided by Ka, Ka is equals to 1 divided by Kp. And if you were given one value of Kp or maybe Ka, you have to calculate the Ka or Kp respectively by 1 by that value. This is the relationship between Kp and Ka, coefficient of active and passive earth pressure. Up to this, any problem, any confusion? If no, then we may proceed to the next part, that is earth pressure diagram. Earth pressure diagram is nothing but the diagrammatical or uh, representation of earth pressure in a graphical figure. Graphical figure means obviously earth pressure, this is lateral, this earth pressure means exactly the lateral earth pressure, and graphical representation means in graph how we have plotted the values of different points. We have to plot the different points of earth pressure, different points of earth pressure at different points of the retaining wall or in the soil. We have to plot the values in a graph where the values are actually representing the x-axis. The x-axis will represent the values of the lateral earth pressure, and y-axis will represent the height of the retaining wall, or maybe you may say the depth of the soil, height of the retaining wall or the depth of the soil from zeroth depth, that is the surface at the surface. We may take the example of this one, the this retaining wall. This is at this position, the value of the depth of soil is 0, that is the surface of the backfill, or this surface of this field may be considered as the zeroth depth, that is here the depth is equals to 0. And how you will go through the soil, through the depth of the soil, then the value of this depth will increase. And obviously, by this equation, by these equations, this is nothing but, or this equation, the general equation, this equation is nothing but equation of a straight line. This straight line having a slope of this, where h is the variable. H is nothing but the height of the wall or depth of the soil. Now, as the height of the wall is 0, then this, or this one is 0. That means starting from this, if there is no wall, there is no lateral earth pressure. That's why starting from the zeroth depth, we have to consider the value of h is equals to 0. That's why we may modify the equations as a variable z. This z is nothing but the depth of soil, and first I'm considering the active earth pressure, where this h is actually replaced by z, and z is here the variable, and z is nothing but the depth of soil from backfill surface. Depth of soil from backfill surface, and this is for cohesive soil this one is for cohesionless soil. In both the cases, I have just replaced H with Z. Z is the depth of soil from the backfill surface. In case of PP also, passive earth pressure, the equation will be modified in a same manner, that is, H will be replaced by Z. This is for cohesive soil, where the value of C is there, and this one is for cohesionless soil, where the value of C is 0. Sorry, this. Now, from the equations, this is clear that all these equations are the equations of straight line, but in different forms. These two These two general equations are representing one straight line, but with some intercept in vertical axis. But these two equations the equations for cohesionless soil. These two equations are actually the general equation of straight line with no vertical intercept. No vertical intercept, that means straight line is passing through the origin or the 0 0 point. These two straight line are representing these two equations are representing those types of straight line. That means these two equations are simpler than the other two, that is the equations for cohesive soil. But all four equations are for straight line, and that's why, as these two equations are simpler, then we may first start from these one and this one. But these two are for different types of earth pressure. That's why starting from this one, first of all, you have to calculate Ka, coefficient of active earth pressure, or Kp, coefficient of passive earth pressure. Then it will be given the value of gamma, that is unit weight of the soil. Unit weight of the soil will be given this value, 1 minus sin phi divided by 1 plus sin phi, or the reciprocal of that will be calculated by from the value of phi only. That means will be given the value of phi. That means angle of internal friction of the soil will be given, and the unit weight of the soil will be given. The variable is z. Here the only variable is z. That means constant one constant may be a b c, like this, one constant multiplied by z, and this z is the depth of soil from the backfill surface. That means if we I'm changing the presentation to one Excel sheet like this. I think you may see the Excel sheet, and if we have the value of phi and gamma as a constant value, then Z and PA, that is active arc pressure, Z is from starting from 0 to maybe 14 meter. If the height of the wall is 14 meter, then obviously the depth of the soil up to the bottom of the wall, bottom of the retaining wall, will be 14 meter. As an example, I'm just taking one example, a retaining wall with 14-meter height. Sorry, retaining wall with 14-meter height. That means the depth of the soil from the surface of the backfill to the bottom of the wall will be 0 to 14, and if the value of gamma maybe we can take it as 20 kilonewton per meter cube unit weight. Value of gamma and if the value of phi is maybe value of phi may be 30 degree, then the value of Ka is equals to, you may calculate 1 minus sin phi divided by 1 plus sin phi, that is equals to 1 divided by 3, 1 by 3. Okay, and Pa, from that Pa equals to nothing but Ka, sorry, 1 by 3 means 0.33. Okay, and Pa equals to Ka multiplied by gamma multiplied by Z. Oh, sorry. For depth equals to 1 meter, same Pa equals to Ka multiplied by gamma multiplied by Z. For depth 2 meter, same Ka gamma z. Like that you may calculate yourself. These values will get. Now if you want to draw a graph from this value, then that graph will be actually called arc pressure diagram. Now coming to the word, this is the graph. X-axis will represent the values of arc pressure and y-axis will represent the value of the depth of the soil from the backfill surface. And I'm just copying the values we have get after calculation in the Excel sheet. If you plot these values, this one is Z and this one is PA, then you will get a straight line like this. Like this, where this one is the maximum value 92.4, this one is the maximum value 92.4, and this is the height of 14 meter. This is the height of 14 meter. This is the maximum value 92.4, or in general equation that is Ka gamma h. This is the value, and starting from the surface this is 0, and all these values are actually these length, these horizontal length. Like you all know the plot of different points with some values like this. These points are representing actually all these points. This is actually the earth pressure diagram. Okay, for today I am finishing the class. In the next class we'll draw and plot the earth pressure diagrams for different conditions with different values of soil density and pi. All those different cases we have to plot, we have to draw the earth pressure diagram. But for now I am stopping the class. Okay. Yes. Anyone want to say something? You can speak out now if you have any doubt up to this. Okay, I'm stopping the presentation. Okay, okay. I'll send the note and the video lecture link. You please study the note and watch the video, and maybe in the next class we'll have some doubts. We'll discuss on that. Okay, okay. Thank you. Someone is asking about thixotropy. Okay, about thixotropy. Actually, thixotropy is nothing but the regaining of soil strength. Regaining of soil strength. That is, when some soil is uh, remolded after taking from field, then after some time it may be remolded and some strength of the soil will be regained by the soil itself. That property of soil is actually thixotropy.